So good afternoon, everybody. I think it's already 2 o'clock and people will be coming into the hall. It's a bit quiet in here at the moment. Everybody are good after the lunch. Probably too good or not. But I hope you will not fall asleep though. This morning we heard the plenary, for example, with the strategy thinking of the future, among others, and about the infrastructure in Europe. And now we are a little bit back to earth again. So from the political side, we are getting back into the implementation challenges. My name is Eydís Líndal Finnbogadóttir. I am from the National Land Survey of Iceland, and I will be the moderator here today. We have 4 speakers. And each speaker will have like a 15 minutes, maybe 16, and to introduce for us what they have to say about the implementation challenges. After each speaker, I will invite you to ask some questions, but we will still try to keep the time limits. In the end, there will be also open questions for all the speakers. Then, of course, the implementation challenges, we still have people coming in here. The implementation challenges are variable. I myself come from a country with only 350,000 people, where we still are to implement the huge initiative of Inspire. There are definitely challenges there. And so for me as well, it will be very interesting to hear what you have to say. So I will just introduce the first speaker here this afternoon, and that is Veronica Kushowa. And please, Veronica, she comes from the Land Survey Office of Czech Republic, and she's going to present the experiences with the creation of Inspire Elevation TIN dataset, according to Data Specification on elevation. So Veronica, the floor is yours.
So thank you. My name is Veronica Kusova, and I would like to introduce you our main issues that we are struggling with or during the process of implementation of Inspire compliant TIN. Data specification on elevation supports elevation data using 3 different representation types. It's grid representation, which provision is mandatory, then vector representation, and the last one is TIN representation. In 2015, our office transformed National Elevation Grid dataset into Inspire compliant grid, and 1 year later we launched a web coverage service, and now we are trying to implement Inspire TIN. There's a definition what is TIN. I suppose that everybody knows it. And there's a question, what exactly is Inspire TIN? I've borrowed an UML diagram from the data specification, and you can see that elevation TIN feature type has some basic Inspire properties like Inspire ID or voidable begin lifespan version and end lifespan version, and it carries other information about the property type and surface type. The geometry is represented by a geometry type, GM10, that is set in ISO standard 19107. And it's defined by break lines, stop lines, maximum lengths of the side of the triangles, and control points, at least 3 control points, with the known elevation value. So the elevation values are stored as the third coordinate, as the Z coordinate. And it's worth noting that data specification works with the concept of tin from ISO 19107 and doesn't work with the concept of tin from ISO 19123. So one elevation value is not assigned to each triangle. One elevation value is assigned to each vertex of the triangle. And where to start the implementation? Then with the source data. Source data for the implementation of TIN, in our case, is a digital terrain model of the Czech Republic of the 5th generation. The data was acquired by airborne laser scanning. It's represented by discrete points with this vertical total standard error, and the used coordinate reference system is a Czech national coordinate reference system, and elevation values are stored in Baltic vertical datum after adjustment, and the files are provided in the data format .xyz. And for the implementation, for our implementation of Inspire 10, we haven't got any source data for break lines or stop lines. So due to the fact, or as you can see, that source data set is not available in Inspire compliant reference systems, the transformation of a coordinate system is the first reasonable step. And the data specification does not offer so many options how the third coordinate can be or what kind of coordinate system can be used for the third for the use of third coordinate. The third option is that you can use three-dimensional coordinates, geodetic coordinates, and the second option is that you can use 3D compound that consists of 2D geodetic coordinate system, and then for the vertical part is vertical coordinate system. And data specification offers only this one option, so we have chosen this. And the second implementation task, or the second step, is that we need to find the optimal way of encoding. So the isogeometry type 19107 GM10 is implemented by GML10, and here you can see their main or mandatory elements. It's a maximum length of the triangle side and control point that covers the points or the vertices of the triangle. And then it inherits a mandatory element GML patches that covers the triangles. And Geographic markup language offers three options how we can encode coordinates, and this approach is for control points as well as for triangles. And here you can see the examples of the encoding. So, when we are trying to find the most optimal way of encoding, the first thing that we were thinking about was the volume of data, because or due to the fact of quite high volume of the source data, because the source data set has approximately more than 1 point per square meter. So, as the most effective way of encoding, considering the volume of data, was the use of GML position list for coordinates of points as well as triangles. It's this approach, and in comparison, the least effective way of encoding was the use of GML pos for or element GML pos for coordinates of points as well as triangles. And you can see the results. The effective way of encoding for the whole territory of the Czech Republic, the volume of data is more than 4 terabytes, and for the least effective way of encoding, it's more than 10 terabytes. And I gave here the comparison with the size of the source dataset, and it was only 280 gigabytes. The second thing we have to consider is the ability of GIS clients to read this kind of geometry, because GML10, it's not a simple feature type, and we've tried to find some GIS clients and we tried all the options of encodings, but we haven't found any yet, so it's quite bad. And here is the main part of the simple file. So you can see that we aren't don't provide break lines or stop lines, and it's the tin that consists from 2 triangles. And now to the data provision. The first thing and the most easiest thing is the creation of predefined data sets, and we have been thinking about things like what is the best size of delivery of export unit and so on, but with the tin, there's connected another issue, and is the question of connection of triangles on the boundaries of export units, because as you can see from the picture, the triangles intersecting the boundaries of the export units doesn't have at least one vertex in the particular delivery unit. So these triangles are missing for the user. And the second thing is the data provision via the direct access download service. And the third thing is to use a web coverage service. But as I said, we launched web coverage service 1 year ago, but our software supports only web coverage service in the version 1.0.0, and this version of web coverage service has no support for non-raster coverages, so we cannot use this. So the second option or the second idea was use web feature service, and here we are facing the question of what is one thing, because as a user of web feature service, you know that you have to set the number of features you want to get. But what is one thing? Oh, it can be, for example, 100 triangles, and can be one triangle. So with this question, we are getting towards to the provision of predefined data sets, because we define that one thing is, for example, 1,000 triangles. So it's a question. And now, to the conclusion. As a conclusion, I want to summarize the main issues we are facing with implementation of TIN. The first thing is the huge increase of data volume after the harmonization. It's connected with the fact that there is a duplicity of some data, because you need to store vertices as well as geometry for the triangles. The second thing is the ability of GIS clients to read GML-TIN geometry. And I know that there are a lot of experts, at least in this room, so I will be thankful if someone of you can give us some idea about this issue. And the last one is how to provide our TIN dataset through direct access download service with using web feature service. And it's all. Thank you for your attention.
Yes, thank you, Veronica. And she asked the question herself into the room. So is there anyone that could answer that question? And do you have any other questions? The question, yeah? Could I ask you to wait for the microphones, because it's for the recording? Thank you.
Thank you. Just a question for Veronica. At this moment, this special representation type, the TIN models in the Inspire elevation, the specification is just optional. So yeah. I think that it was introduced, if I'm not wrong, in order to give another possibility, and maybe if this special representation type or format could provide some kind of added value for users. What's your opinion about that? Do you think, as a elevation expert, do you think that it provides something more, or do you think it's unuseful for Inspire specifications to treat this special representation type?
I think that one of the main problems is the ability of GIS clients to read this type of geometry, because if there isn't any software, I think it's not so usable as it could be. And the second thing is, or other problems that are connected with the GML geometry or the TIN model itself, is the no topology, or it's or no indexing of triangles and so on.
Okay.
Any other questions? No, not at the moment then.
Me as well, I think.
Sorry.
So I didn't catch exactly your question about the problem about the direct access WFS service.
What is
web feature service, which is the problem there?
What version of
I think your question that you asked the cloud there about the client.
yeah, I asked about the clients for GIS clients for the geometry.
Yes, the other one related to the web feature service.
Yeah, if there is
the
some GIS clients for web feature service.
Okay.
Okay. So thank you, Veronica. I think we will move then on to the next speaker, and you will be here. So if you have questions, you will get the chance of asking them in the end as well. The next speaker is as well from the Land Survey Office of Czech Republic. That is Pavel Shilikovsky. I will get it. And he's going to talk about the Landuse Dataset Derivation from fundamental base of geographical data. It's a feasibility study.
Yeah, thank you for the word. So I would like to introduce to our exercise, which we did recently. The brief contents of my presentation is why are we even trying to do such a thing? What are the required results? Short introduction: what data we want to, from what data we want to derive the data set, how did we approach the problem, and how the possible result may look. And well, and as a conclusion, how bad or good the idea it is, and how useful the result may be. Just to start at the beginning, very short introduction. How the INSPIRE implementation is organized in Czech Republic. It's under responsibility of Ministry of Environment. It was transposed into Czech law by amendment of the Act on the Right to the Environmental Information, and there was a committee established to supervise this process as an advisory body for Minister of Environment. In last year, there was a revision of how we are doing with implementation, and the effort is to provide at least one data set for each team for all annexes. So the land use team is assigned to Ministry for Regional Development, mainly because there is no competition in providing the future land use data, of course. It's under their responsibility. But it's often said that land cover and land use has a lot of in common, but on the other hand, they are in a lot of things different, mainly because land cover just happens, but land use, at least in Czech Republic, is subject to a lot of regulations. I listed some of them, like Forestry Act, which deals with definition, what's forest purpose, parcel, Water Act, Act on Protecting of Agricultural Land, which defines what is the agriculture plot and what is not. And of course the Act on Town and Country Planning and Building Code, which is self-explaining, but the important part there is that it defines what's built-up area. So this some of the laws. Also, as a minor law, but interesting still, is the Hunting Act, which defines that hunting grounds could be anywhere outside of built-up areas and transport networks. That's transport network include airfields, but only those with solid runways. So any grass strip is fair game. As you can imagine, all those laws have impact on value of the land. So the land use data set itself is, at least from my point of view, a very sensitive thing. The complication here is that many decisions according to those laws, the state is represented by municipalities. When we have over 6,000 municipalities in the lowest order, which are then aggregated into higher order municipalities for some purposes, but at the higher order there are 205 municipalities still. So the information about permitted and so on land use is fragmented a lot amongst those municipalities. Some decisions may be registered into cadastre, but it's responsibility of the owner to forward the decision into the cadastre, so the data there are not completely correct. That's why we were asked to come into this thing and try to produce a land use data set not based on those legal decisions and so on, but based on observed reality from geographical data, if possible. Here you can see how municipality plan looks. So we have something like 6,000 islands like this, which somebody would have to fit together to produce a single data set of land use, which will take time. So in the meantime, that's our place to try something. As a side step, it's interesting how differently the land cover and land use data specifications approach to the same problem, because at the beginning they used very similar words to describe their problem, but came to quite different conclusions, where land cover allows any nomenclature, any classification, as long as it's described properly, but land use introduced so-called mandatory HILAC code list, which defines mandatory classification. This code list probably is known to you, so just a short overview. It has overall 98 code values, so it wouldn't fit in the list, but those are more important values from a geographical point of view. I would like to draw attention to the last column. There are color codes for view service, which are defined by specification, and as you can see, only few values have a defined color, and it is said that provider can extend the coding if he needs it, if he considers it necessary, but should keep in line with already provided coding. So, for example, from my own point of view, I have a problem to define color for mining and quarrying in a green area, but okay, it's just cartographic point of view. The source data set we use is our fundamental base of geographic data, which goes back to the year 1995, where when we started to vectorize base maps, it inherited some classifications, some some features are together in a common classification group, which then comes to haunt us. Now the first updating cycle of this database is finished. The main improvement in the meantime from the 1995 is improved accuracy and some enhanced attributes. We have, as you can see, some numbers. So 16 million individual objects and over 100 million vertices in the database at the moment. So what we actually did, we created a matching table, as is usual in Inspire implementations, harmonizations. This is just an example because this matching table has some 80 lines of useful combinations of feature and its attribute. And we assigned in those last columns, we assigned the hierarchical numbers from HILUX as far as we could go. So sometimes it's just the first level, but mostly we end up for the second level of the code list. The third one, the third layer was used just for information for us what's supposed to be in the category. So in the first run, we were able to assign out of those 80 lines 64 feature attribute combinations to HILUC values, but those 64 feature attribute combinations covered just 4% of the area of the country. Those were those things which are almost land use, like vineyards or industry areas, which were defined already in the source data set mostly as land use. So not surprising feedback from our management was be more brave. So in the second try, we assigned almost every category to best fitting Hilux value, including the forests and arable and other aggregated feature. This is one of those inherited from base map. Orchards and gardens, also aggregated feature type, which then brings us some difficulties later. So we improved the coverage to 97% of the state area. What remained unclassified is waters, because we have absolutely no information about use of water. And then there is problematic attribute value other industry, which in our classification includes many businesses which would be otherwise classified as services, but includes industry as well. So those we were not able to assign on even on the first level. To see what we did in the matching table, we set up a WMS service, which is accessible to, well, anybody if he knows where to find it, because it's not a view service full-fledged. It doesn't have metadata. You can't discover it. It's just for our internal purposes, but it's public. Here you can see a sample from our GeoPortal viewer how this service looks. And it was intended for checking if there are any gaps or nonsenses from the classification. So it has several cycles of improvement, but it's still not very good. Difficult categories are forests, because we don't differentiate forest in any way, but Forest Act knows 3 categories of productive forest, protective forest, which is like hill, ridges, slopes, and some difficult terrain where we are happy that something grows, so it's not productive forest. And then special purpose forests, which main purpose is something else than production, like recreation, protection zones of national parks, and so on. And also from the Act, it's defined that there are parcels with purpose of forest production, which may have no trees, which is also something we are not able to reproduce from geographical data. Then I mentioned the agriculture and other feature, which happens that because we have our transport network expressed just by lines, and that it covers also the area of roads and railroads. So we need to differentiate this. It was easy, relatively easy to do for railroads, where we came back to construction norms and standards, and we found that we can easily create a buffer of 4 meters around individual railroad tracks, and then aggregate it into a rail area, and it works very well, except of course in rail yards and so on, but those we have in the data, so it's not a problem. So in country we can do this area easily, but this buffering, this is how it works with the data. But this approach couldn't be used for roads, because they have greater variety, and even if the width of the road is known, it changes very often and doesn't really express the area of the road very well. So we have to come with something else. And what we tried is analysis of the image in similar way as the cars do it. So we try to find from the image the vertical markings on the road, and to recreate from this the road itself. We do profiles along the road, and then by comparing nearby profiles, we exclude the extremes which are not good. It works well for simple cases, as you can see on the right, but it works reasonably well even for the more difficult cases. But of course, it will never be the automated process, so it could be used only as aid for some semi-automatic vectorization. We hope we don't have to do this. We hope that road management will come with a better data set from construction plans or anything, but if not, then this is what we will have to do. Another challenge, I said, we have orchards and gardens in one feature. That means that some built-up areas were classified as agriculture. We couldn't help this because, well, gardens. Those houses have gardens, and probably it should be a residential area. But what if those gardens are used for production for their own need, which is one category of hylocks? Then it would be agriculture, or not. So this is something we cannot differentiate from our data or any other data. So we are not able well automatically to reclassify the residential areas. It doesn't look good even in city centers, where we have aggregated the area of the buildings and the streets, but we considered it strange to include individual buildings into the land use dataset of the scope of the country. It could be included in the dataset of the scope of the municipality or anything, but for the country it doesn't seem like a reasonable solution. Last, well, maybe a bit funny thing, I said we have nothing concerning use of water areas. There is a category called aquaculture, which probably means something like this on the picture. But in Czech Republic, there is a long tradition of fish farming. This is fish pond in Czech Republic, established in 15th century. And it really is built with the purpose of fish farming. It's pond Bezdrev. It has some 5 square kilometers of area. Is this supposed to be aquaculture or fish farming? I'm not sure, but it is farmed pretty regularly every 2 years, and it produces about 250 tons of fish every year, or 500 tons every second year. But of course this area is used for other activities like recreation and even yacht races, regattas, so maybe we can do a split use of 3 categories, but I'm not sure which is the most important one. Conclusions. We can create a land use coverage with close to 100 area covered from geographic data with some additional work. But such dataset could not be considered authoritative data, because it would not include the decisions, permissions, and so on. So there is a question of how to use this data set. I think it would be useful for regional general idea how the land use looks, but of course in detail, in comparison with spatial plans, for example, it fails completely. If somebody would try the analysis how land use is changed in spatial plan based on this, the results probably would not be too close to reality. But I think this dataset could be used in the future when authoritative data will be put together. Then our dataset could be used for cross-checking or reality checking of those data to find and correct possible errors. Well, disclaimer, you can see it's just exercise and probably will not be realized in this form, but some lessons will have been learned for us and for the future dataset. And that's all from me. Thank you.
Thank you. Are there any questions or clarifications that you might want to ask? Yeah, there's one in the back. I will have to wait. You have to wait for the microphone.
It was a really interesting presentation, and it shows us the complexity of the land use team. My question is, are you thinking about using cadastral data to combine with this from base maps data, at least for the roads, because maybe it is a solution for the delineation of the land uses?
This is area where I would get on, we call it thin ice, so something where I can step very easily in the wrong way. But to specifically answer your question, for roads, we are not thinking about it that much, because roads were built in a long time, and from my own experience, the representation of roads, the older roads, not roads built in recent 20 years, but the old roads are not represented very well. So for roads, it wouldn't be useful. Of course, we can improve this data by integrating more external information, even from cadastre. For there is some, I said, there is registered some information about land use, but then we are denying the purpose of this, which was to keep it simple and use single data set. So it's subject of future decision making if this is a way, if we should expand this and improve it and make it more complex and difficult, because there will be conflicts and so on between various data sets, or not. But definitely we are thinking about what data we could use from other sources, but the purpose of this was to not use data from other sources.
Okay, thank you for that, Pavel. And I think we will have to have further questions in the end of this session. So thank you again. And we will move to the next speaker. And that is Christian Schwarz from Codematics. And well, he's going to speak, and let me see, this is a challenge in itself, the name of your presentation. Yes. The challenge and issue of data transformation for a heterogeneous source in the example of creating an inspired harmonized federal waterway network. Wow, I managed that. That's well done.
Thank you very much. My name is Christian Schwarze from the company Codematics, and I want to talk about a project creating an Inspire-compliant waterway network of Germany. And on the left side, you see the initiator of the project. It was the ITZ Bund, located in Ilmenau. It is the IT service provider for mainly federal agencies and responsible for hosting and operation of IT administrative processes. And on the right side, you can see the company I work for. It's Codematics, focusing on geospatial software development and IT support and GIS software infrastructures and data processing. A few words about the WSV. In German, it's the Wasserstraßen- und Schifffahrtsverwaltung des Bundes. So it's the Federal Waterways and Shipping Administration. It's an executive agency of the Federal Ministry of Transport and Digital Infrastructure, and responsible for secure and efficient shipping traffic, and also responsible for Inspire-compliant data processing and provision. At the beginning, there was a feasibility study as well, how we can use various concepts for processing data from heterogeneous data sources. And to develop approaches where we can extend these approaches very easily. So we combined various techniques, for example, XSLT as a transformation language for GML documents to transform XML documents to other XML formats like GML, for instance. There's another tool we used, it's OGR, as a collection of tools for geospatial data manipulation, for example, and the third one is Java as a object-oriented language, and combined with various libraries, for example, GeoTools, you can extend this language. So I talked about I talked about various data sources. I mean, FERCnet. FERCnet is the German transport network of inland waterways provided by the Federal Institute of Hydrology. The second data source is the inland electronic navigational charts, also by the WSV. And we have a third data source, the waterway database, also administered by the WSV. A couple of words to the FERCnet. It's very technical, complex due to professional information and high-level detailed attributes. As you can see, the geodatabase behind, and very complex relationships between the geometries and so forth. Example, the red lines, you can see we distinguish between secondary waters and main waters, and between there are simple connection lines, virtual connection lines, you can say. The second data source, the navigational charts, contain a variety of object-oriented designed vector data along the inland waterways. And the third data source is, as I mentioned, the waterway database, containing a lot of objects located along the waterways, either owned by the WSV or by any other third party. I want to skip this slide because it's very complex. It's the scheme from the Inspire Transport Network data specification. As you can see, it's very complex data structure, but you can say you have an inland waterway that consists of a couple of waterway links, and one waterway link contains waterway nodes, and you have water nodes like turning basins or ship locks or terminals or ship lifts, and you have a special nodes, water nodes like ports. It's a special water node, as you can see here, for representing the point of a port. And you have special waterway links like ferry crossings or special areas like port areas. So the challenge was to map these three data sources to such a scheme. And with the OGR or XSLT, we, as I said, the FERCnet data source is very complex, and we need to break down it to the main relevant components, like junctions and waterways itself. And therefore, we used the OGR tools and XSLT, for instance, to eliminate only the junctions on the left side, and the regarding to the junctions the waterways. And as you can see here, the red lines are also again the connection lines. And also for the water nodes, we used OGR XSLT on the WADABAR data source for retrieving relevant facilities along the waterway. Therefore, we used the web feature service, which is available, and requested only logs, ship lifts, turning basins regarding the Inspire data specification. And also, this shapefile, which is the output of this preprocessing step, will be used later in a Java data processing step. Also for the port areas and for the special ferry crossing lines, we used OGR XSLT, but now with the navigational charts, you remember, it's a third data source. And we querying the navigational charts for relevant objects again, in this case for harbors and ferries. And the resulting shapefiles are used later in the Java preprocessing step as well. So I told about, I mentioned Java as a preprocessing step. Especially for the waterway lines, we used Java because, as you can see, we don't want to use in the Inspire dataset these connection lines, because the Inspire scheme or data theme doesn't mention such connection lines, so that we want. So that's the reason why we want just to merge these lines. So we want to skip and ignore these connection lines and create or build new lines that are continuous lines at the end. And therefore we use, for example, Java. At the end, all the Java tools produce SQL commands that load these features, these final Inspire features, into a database, and the software degree we are using for providing WMS, for instance. Also for the water nodes, we used Java as a processing or preprocessing step, because all these three data sources or the geometries of the data sources are not harmonized necessarily. So that means the point is not necessarily on a line, so that we have to snap it first onto the line. As you can see, for instance, snapping points, for example, locks or ship lifts, to the lines from the FAIRCnet, and that's why we are using Java as a preprocessing step, because we can do there a lot of geospatial processing, for instance, with these library geotools. And as a result, we got, for instance, a couple of GML documents where all these IDs also processed by Java are contained. And a last thing about Java, we also create the port nodes with Java tool, with Java code, because as Inspire said, a port node is a point to represent a sea or inland port in a very simplified way, but approximately located at the bank of the water body. So with Java, we can easily construct such a point from port areas which are located on the boundary of the port, but also in the most cases on the riverbank at the end. So, and here it's the same. Java code produces SQL, so database commands, and the degree software in the back end is responsible for serving the WMS, for instance. And as a result, you can see here the final WMS showing all these Inspire feature types like waterways, waterway links, port nodes, port areas, and so forth in a WMS. And as for example, also here in the left side, the WMS get feature information with all these attributes which are required by the Inspire data model. Thank you.
Are there any questions or clarification needed? I'm sure you have some. None? Yeah, of course there are. Yeah. Excuse me, could you wait for the microphone? Yeah.
So is it already available for public, or is it?
It's available. I just forget, I think, the URL of the WMS, but you can access the WMS. It's available for sure.
Okay. There were more of them.
Did I get it correct? Is this just an exercise for Inspire, or goes this result back to the original authorities who
Yes.
keep the data? Is
Yes.
there an added value for
So it,
the original data sets?
The final results do not replace all the data sets, of course. So we created new data sets, Inspire compliant data sets, and created Inspire compliant documents, GML documents, but also the WMS, for instance. And these services are available and do not replace other data sources or services. And it's a productive service.
There was one more question here.
You just said it's just available as WMS. Is it also available for download as WFS or something like that?
At the moment, not via a WFS, but as an atom feed, where we have some predefined data sets. For instance, waterway sections for the Rhine, for example, and so predefined data sets you can download via this atom feed,
Okay.
containing the water nodes, for example.
And will that be the official Inspire services for Germany for the transportation network theme, or is that?
Sorry, I
Will
missed
that be
the first part? Sorry.
Will that be the official Inspire services for the transportation network part?
Yes.
From Germany?
It's already
It is already.
It is
okay.
already.
One last question. Are you planning to extend it to the sea?
Sorry?
Are you planning to extend it to the sea? Because it's just inland water what you're looking at.
My focus was on the inland waterways. There is also the WMS also covers the coastal regions, but there are other pre-processing steps needed. So this was the reason why I skipped it in this slide. But the WMS and also the atom feed covers also the coastal regions with, for example, this traffic zones in the
separation schemes.
separation schemes, right? And yeah, it's also contained in this data set.
Okay, thank you.
You're welcome.
Okay, thank you, Christian. And then we will move to the next speaker. That's our last speaker today, and that is Anders Rydén. He's from the National Land Survey of Sweden, and he's going to tell us about how to keep it simple while implementing Inspire. It's a Nordic view on technical simplification issues, needs, and possibilities.
Thank you. Thank you. My name is Anders Rydén. I'm a national coordinator from Sweden, Inspire coordinator. And thinking about this, thinking out of the box, what we're going to do now, what I'm going to do is maybe trying to take this outside the box. And this presentation maybe should have been called looking at the box, trying to figure out what will you face when you enter. Because if I shall give a background, I'm talking on behalf of the Inspire network, which is an informal network by the Nordic national coordinators, the Nordic contact points, and we were formed some few years ago in order to share experience and knowledge. And what we have done in this case is maybe addressed in particular to the work within the fitness for purpose, looking at how we can make Inspire more user-friendly. And we have, in this case, collected some experiences of challenges that our authorities are facing when we are kind of having our ear to the ground. because as a national coordinator you are kind of having continuous discussions with all authorities, and we have tried to put that together, and we'll try to give you an idea of what they are facing. I will skip the history lesson there because I think time is running, but the castle there is when the Nordic countries were put together into one union in 1397 under Queen Margareta. Before I go into the actual simplification, what we are going to propose, or we are going to show you, and with some proposals on what we propose can solve this or make this more fit for purpose. I just want to make the statement that we don't see this as the only area where you can make Inspire more fit for purpose. There are, of course, a lot of other issues or topics that can be addressed as well. And I know at this conference that all of them more or less will be addressed. The problem here, I don't see what the next slide is, so that I will have to try. Anyway, going into Inspire data models. Being a new authority, or also being an old authority, but having to enter this field of harmonization might not seem so difficult. This is an Inspire model from the area management specification. There a central table with some few mandatory attributes. There are avoidable attributes and some relations, associations to this one. No big deal, you may think. But looking deeper into this one, now if you would be an authority having to harmonize your data according to this model, you will start to look deeper. You will soon discover that some of these attributes are nested, meaning that one attribute consists of several other attributes, which actually in other cases, in even a second step, consists of more attributes. So if you unfold this model, it doesn't look so simple anymore. So this is what a authority will face. And this is actually a main complaints or concern, I would say, not complaints, concern by many authorities, that these complex nested data models are too difficult to implement. Not mention that there, as was mentioned earlier, that there are very few softwares that can actually read this one. Anyway, the content is this one, could just as well be put in a flat model like this. In this one, we have taken all these attributes, putting them into one single table. It becomes quite long, quite difficult, but still it's one table. And it actually provides the same type of information. If you would match these two, they're exactly the same, just described differently. So what we would like to do, our first kind of view together, is to challenge the conception that we need to have complex models, because these two models, or the flat table and the complex model, does actually contain the same information. We also think that the directive gives room for both of these ways of presenting data. These complex models are recommended in the technical guidelines, but there's no actual requirements to use these models. Now, it's not like we are not acknowledging the complex models and we're actually promoting them. But being a new authority, maybe with a data set of 200 to 300 point objects, having to implement with 3 or 4 attributes, having to implement this complex model, may be a little too big step. So we think that these two models should both be Inspire compliant. I'm just waiting for the pictures. Don't forget me. Okay, so that was number one. This could also be accentuated by the fact that irrespective of what model is actually used, in your software, in your application, querying a object, you will get the feature attributes, as in the Windows here, independent of what model is in the background. Makes it a little bit difficult to convince this authority with their 300-point objects that it's much better to use the complex model instead of the flat model. So that's one of our suggestions when it comes to making Inspire more fit for purpose. Going into details, something many authorities are concerned about or having problems with. Now I say problems, but to be completely sincere, if you talk to the authorities, many authorities say that there's no real problems, everything is solvable, but it's the amount, everything is adding up to become, when it becomes too much. Anyway, voidable is one of these three issues we wanted to raise. The first four attributes here are avoidable, compulsory, and the rest avoidable. And if you put this one, just to make this a bit over-exaggerating it, the first one, Inspire ID, consists of two parts, the upper two there. You see a number of red, those are the unknown ones, the avoidable ones. And then you have actually two attributes in this table here. So many may wonder, do I really need to put all this unknown in? Because they are cluttering my attribute table and my query. And this thing now in Inspire says unknown, unpopulated, and withheld. Now we all have to follow this one and add all these attributes to our data, and we could actually wonder if it's so important to know if a attribute is unknown, unpopulated, or withheld that it actually justifies forcing everyone to put them in. Now we can acknowledge maybe that these attributes are put there on purpose. I think they are, because they are probably desirable. We would like to have them there. But putting attributes there just because we would like to have them there is not the same thing as forcing everyone to actually create all those columns in our attribute tables. Because today's softwares, and maybe also yesterday's softwares, most of them were created in such a way that if you merge two data sets with different attributes tables, you get a number of different choices on how you want to have the attributes merged. This is from just a screen dump from a manual of one of the more popular softwares. So what we do, we propose that these voidable objects are not, it shouldn't be necessary to put them. They are desirable, but should not be compulsory. Flattening of complex attributes, that's a nice one. Now I'm just taking an example here of, this is Denmark. Anyone from Denmark? No. Of an area. We have our query with the attributes coming up. There are a lot of unknown. Then suddenly, oops, one area got a name. That's no big deal either, actually, because we have this name, unknown, or unknown it says there. So can you put the name in there? Piece of cake. What happens? To put that name in, that's one of the nested attributes. So before you can put the name in, you have to go to the next table there, and you get a number of attributes. And that in turn is nested, so you have to put even more attributes in, which creates a mess for this authority having to do this one, because in your attribute table it look like this. I just kind of, the first one are the ones maybe that you would like to have, the compulsory ones with the Inspire ID and a namespace and version, I think, zone type. The rest there are the name attributes. Now, just because that area suddenly got a name, you have to put on this also. Otherwise, you just can avoid this one. Do you see the name? It's there. So, I'm very fast. This took 20 minutes yesterday. So actually, to summarize this a little bit, is that we acknowledge the complex data models, but as conceptual models. We are moving in that direction, but we think that we need to allow flat data models as well. They should also be valid, Inspire data. We think that the voidable attributes must be left out, or must be, but they should be left out. It's of course voluntarily. If you want to put unknown, 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 it's up to you, but we don't think they should be mandatory to put in. And as we saw, most modern softwares handle this one when you different attributes tables merged. And we think that these complex data types, now we saw geographical names where you have, when you relate to other schemas or to other standards, has to be done easier. In the case of geographical names, there are room already in the specifications that it's up to each TVG, that is those ones writing the specifications, now maybe it's too late, to suggest ways of putting names without having to go all this step before you get the name. In other cases, there are also, I would like to refer to a position paper done by Denmark, where they explain a way of making this easier in such a way that you can kind of re-engineer from a flat model to an original complex model. Am I right, Lars? And yeah, I just wanted to give you a good example of the simplification, and this is from Denmark. You can recognize the name with a name there. This is an actually perfect fit-for-purpose data set with some few attributes that are also fit for purpose. It's an ID. Yeah, there's some few, 1, 2, 3, 4, 5, 6 attributes there. Applying some of these things we have done now, avoidables are left out, multiplicity changed from 1 to many to exactly 1, and in particular these inheritances are flattened. And then I'm talking about these geographical names and relations to other standards. You select some of the voidable attributes that are useful, because Inspire is actually contributing to our own data, and out comes a table which does have more data, yes, but it's still done in such a way that it complies both to national needs and Inspire needs, and without being kind of giving the authorities an extra burden to create this complex model with a lot of attributes that they don't even know what they are. I think I'll leave room for any question now. So please keep it simple.
So are there any questions to Anders? Yes, there is one.
Not a question, just 2 remarks. It's a really nice idea, but there is one weak point, because every state should simplify in the same way. If you do not this, you will give up the basic idea of Inspire to be interoperable. That's the weak point of we now could speak hours about what is voidable, why is voidable, and so on. But let's imagine that before Inspire has been set up, there were some use cases which should be delivered after the functionality will be finished. And in this case, we give up such a use cases as well in future. And another remark, certainly, we know that some themes like transport networks and so on should be simplified, and it's not very easy to run the services according technical guidance. On the other hand, there are some themes which we had to do more complex, for example, buildings, because our users said the basic 2D approach is for nothing. We have to have a link between addresses, parcels, and buildings, and that's why we need that more complex approach. That were the remarks all.
Thank you.
Do you want to say anything?
It's hard to say anything actually, because it's true. And yes, when it comes to complex, we have to cooperate. We have to discuss also these issues. I mean, the presentation here, as you agree, it's on a general level. If you drill down in this one, we have to. Flattening, I think, can be done quite straightforward, because if you have different attribute tables, there's no big deal to match them or merge them. Flattening when it comes to inherited attributes, that's a problem. That's why I will refer to the Danish proposal, where they have an example on how this can be done. But maybe these discussions we should have is actually on how can we do this the same way.
There's another question there, yeah?
Hi. What you said about voidable elements in the current application schema files. So, for example, you showed geographical names. They have, and they will probably still gonna change the XSDs for all these data themes. What could be implemented and not be that difficult is to change the values for minimum occurrence in these XSDs. Because a lot of these voidable elements have to be there. They can be empty, but they have to be there. And we can just update technically. It's not that difficult to update the schema files so that we can say, for example, spelling of name or I forgot pronunciation of name. We can just say that this can just not appear in the GML file completely. So minimum occurrence is just 0.
I can't say anything against that. I'm not a technician in that. But it's a proposal there.
It's just updating the schema definition.
Are there any other remarks or questions to be asked? No? You can also ask any of the previous speakers if there's still something in your mind. And if not, they will be around. So I will close this session then. And
before you close,
yes,
I would say maybe I'm kicking open doors with this one. But when we discussed this one, it was not a hot discussion. We agreed quite fast. But these few days I've been here, I've heard similar approaches or discussions in many areas here, not at least from GRC. So I think this is a way we're going. So I think this whole presentation is partly kicking in open doors. Thank you.
Yes, that was a good end of this. Good point in there, yes. So we've heard about a lot of different things, so a lot of implementation issues here. And there's several ways of solving it, as we have seen. And hopefully this will be useful for the rest of you to help you in implementing Inspire. So thank you for coming, and thank you for this session.